High in the Bolivian Andes, where the air thins and snow crowns the peaks, stands a mountain called Uturuncu. To the untrained eye, it looks like just another rugged summit, another silent sentinel in a vast chain of mountains. But hidden within this 6,000-meter peak lies one of Earth's greatest secrets. Uturuncu is not simply a mountain. It is a supervolcano, a rare geological titan, capable of shaping landscapes, disrupting global climate, and altering the course of civilization if it awakens. The ancient firestorm. To understand Uturuncu, we must travel back tens of millions of years. Around 30 million years ago, the Central Andes became the stage for one of the most violent volcanic events in Earth's history. Entire regions were buried under ash. Thousands of cubic kilometers of rock were blasted skyward, enough to blanket continents. The legacy of these eruptions still surrounds Uturuncu today, vast plateaus of volcanic deposits, calderas stretching across the altiplano, and layers of hardened ash that tell a story of unimaginable violence. For the last 10,000 years, Uturuncu has remained quiet. No fiery fountains, no catastrophic ash plumes, only silence. But silence, geologists warn, can be misleading. Whispers beneath the surface. The first hints of change arrived subtly. Sensitive instruments picked up tiny earthquakes, imperceptible to humans yet clear on seismographs. Near the summit, vents began to leak gases, steam, carbon dioxide, and faint traces of sulfur drifting into the thin Andean air. Most strikingly, satellites revealed a slow uplift, a dome rising near the summit while the outer flanks sagged downward. Geologists called it the rising sombrero, a telltale sign of pressure building deep underground. On their own, these signs might be dismissed. But together, they form a pattern. A volcano once dormant is shifting. Breathing. Stirring. What makes Uturuncu unique? Not all volcanoes are created equal, and Uturuncu is particularly dangerous because of how it is built. A stratovolcano. Unlike shield volcanoes that ooze lava, stratovolcanoes erupt explosively. Their magma is thick, sticky, and gas-rich, prone to trapping pressure until it bursts with devastating force. A subduction zone. Setting. Uturuncu sits above the boundary where the Nazca Plate dives beneath South America, a collision that fuels volcanism all along the Andes. A hidden reservoir. Beneath Uturuncu lies the Altiplano Puna magma body, one of the largest known partially molten systems on Earth. It stretches over 500 kilometers and lies only 20 kilometers beneath the surface, extremely shallow in geological terms. This underground sea of magma and volatile gases acts like a colossal engine. Even when no eruption occurs, it feeds heat, fluids, and pressure into Uturuncu's core, keeping the system alive. Breathing Earth. Since the 1990s, satellites and ground instruments have confirmed what locals call the heartbeat of the mountain. Every year, the summit swells by a few millimeters. Earthquakes ripple through the crust, tracing pathways of fluids and gas as they search for escape routes. But here's the paradox. Scientists believe much of this unrest is not caused by fresh magma pushing upward, but by gas and briny fluids venting from the deeper magma body. This means the volcano can breathe, producing quakes, uplift, and gas releases, without necessarily erupting. It is as if Uturuncu has a pressure valve, releasing steam but not yet unleashing its full power. Should the world be worried? For now, experts emphasize caution over alarm. The earthquakes remain small, rarely above magnitude 3. The uplift is steady, not accelerating into dangerous spikes. There is no direct evidence of magma rising toward the surface. In other words, Uturuncu is active but not erupting. It may continue to rumble quietly for centuries, adjusting and releasing pressure without catastrophe. But supervolcanoes are unpredictable. A shift in the balance, say, fresh magma surging into the shallow reservoir, could escalate the situation dramatically. The worst-case scenario. If Utarunku were to erupt in full force, the consequences would be staggering, far beyond the quiet slopes of Bolivia. Local devastation would strike first. Cities and villages in Bolivia, Chile, and Argentina could be blanketed in ash thick enough to collapse rooftops, choke the skies, and render entire regions unlivable. Rivers and lakes could turn acidic as volcanic chemicals seep into their waters, poisoning ecosystems and drinking supplies. Agriculture, the lifeblood of Andean communities, would wither under layers of ash and months of diminished sunlight. Livestock, unable to graze or drink safely, would perish. And as jagged ash clouds filled the sky, airplanes would be grounded, severing transport and trade routes across South America. But the story would not end there. A true supereruption does not stay local, it spreads. Globally, the atmosphere would become a canvas of haze. If enough ash and sulfur dioxide reached the stratosphere, sunlight would be scattered back into space, cooling the Earth's surface. Average temperatures could fall by several degrees, enough to disrupt growing seasons across the planet. Rainfall patterns would shift. Monsoons might falter. Drought could tighten its grip in some regions while floods surged in others. In a world already strained by climate change, such a shock could ripple through economies and food supplies, triggering shortages, migration, and conflict. It's a chilling picture, but one grounded in the geological record. Past supereruptions, like Toba in Indonesia 74,000 years ago, left fingerprints of global cooling that endured for years. Utarunku, with its connection to one of the largest magma bodies on Earth, carries the potential to repeat such a cycle. Yet here lies the nuance: not all eruptions are apocalyptic. Most, even from massive systems, are smaller, regional events. They may disrupt lives in surrounding nations without plunging the globe into darkness. This is why researchers study not just catastrophic extremes, but a spectrum of possibilities: modest ash plumes, moderate dome collapses, and explosive blowouts. Preparedness must be flexible, because the Earth's voice can rise in whispers or in roars. A volcano in a larger system. Utarunku is more than one mountain. It is a piece of a vast, interconnected puzzle. Along the backbone of the Andes, volcanoes stretch like fiery beads on a string, all fed by the slow, relentless subduction of the Nazca Plate beneath South America. At the heart of this system lies the Altiplano Puna magma body, a partially molten reservoir so immense it rivals the size of small countries. Utarunku, perched above its northern edge, is one of its most prominent outlets. But the magma body does not belong to Utarunku alone. It fuels a network of volcanoes across hundreds of kilometers. This means activity in one location could influence conditions in another. Pressure changes, gas movements, and heat flow ripple through the crust like waves in a vast subterranean ocean. By studying Utarunku, scientists are not only watching a single peak, they are observing an entire volcanic province breathe and shift. It is a reminder that Earth's systems are rarely isolated. They are webs, linked across scales of space and time. Listening to the Earth. The difference between ancient civilizations and ours is not that we face fewer natural threats, it's that we have more tools to understand them. For the first time in history, humanity can truly listen to the deep murmurs of a supervolcano. Satellites, orbiting silently above Earth, detect the slightest bulges and sags in the ground, shifts of just centimeters that betray the movement of fluids kilometers below. Seismometers, buried in the soil, pick up tremors smaller than a passing truck, mapping how fluids migrate through cracks in the crust. Gas sensors, placed at vents and fumaroles, measure invisible changes in carbon dioxide, sulfur, and steam, clues to the chemistry of the magma chamber below. Computer models simulate futures, predicting where ash clouds might drift, how far lava might travel, and what regions would be most at risk. These tools cannot hold back the forces of geology. But they can grant us something priceless: time. Time to warn communities. Time to plan evacuations. Time to save lives before disaster strikes. The final word for 10,000 years, Uturuncu has kept its silence. Its slopes, scarred by ancient eruptions, have slowly healed under snow and stone. To the human eye, it looks timeless. But beneath the surface, the mountain is alive. Gases shift. Rocks fracture. Pressure mounts. With each passing year, we are reminded that silence is not the same as stillness. The earth does not sleep, it waits. Will Uturuncu erupt in this century? Or will it slumber for another 1,000 years? No one can say for certain. What scientists can say is that the signals are there: tremors, gases, uplift. Whispers in the deep, subtle but persistent. This is not a call for panic. It is a call for respect, for awareness. Supervolcanoes are the Earth's slow storytellers. Their language is written not in minutes or decades but in millennia. They speak through patterns of uplift, through gases in the wind, through tremors that echo in the crust. And now, after ages of quiet, Uturuncu's voice is growing louder. For the first time in history, humanity has the technology to hear it. And for the first time in 10,000 years, the world is truly listening.